equal to e to the power at x0 that we call as the initial condition. This e to the power at is nothing it, that is actually the state condition matrix. So e to the power at x0 plus 0 to t e to the power a t minus tau d tau. This was the solution. This part is the homogeneous solution. It's called unforced condition. This is the homogeneous solution. Homogeneous solution. When the system is unforced, no input has been provided. So depending on only the initial condition is present, how the system performance, system states are behaving, that we can identify from this part. Now again, if we are applying any input u tau, suppose u tau may be state input also. Let it be the state input. We are applying a state input. Then at t equal to 0, we are applying the state input. So when t is greater than equal to 0, this part is getting added with this portion is getting added with the homogeneous solution. We call it forced solution. So here gives us a complete solution of the system. And what type of system? Already we have defined the state model. Suppose we have n number of inputs, n number of states, t number of outputs. So the state equation will be something like underscore t. Derivative of the first order, derivative of the first order derivative of all the states, that is equal to the system matrix multiplied with state equation, state variable, not state equation, state variable, plus input matrix multiplied with input. Now input may be single input or maybe multi input. Here we are writing the equation multi. Like we have n number of input variables, n number of state variables are there. This equation we call as the state. Now also to define state model, we need an output equation y minus t, that is equal to output is a function of all the state variables t into x underscore t plus the input variable. Input variable is ut. A number of input variables are there, which is being multiplied with the transmission matrix, and this we call as the output. Now, the solution of the state equation, or the state variable, from this equation, we are getting solution of, we have n number of state variables, so we are getting solution of n number of state equation, that is given here. This is the solution of one equation only. This we can take in terms of phi t. Already we take this thing, xt is equal to phi t is the state transition matrix. In the class, last class, in the offline class, we defined what is state transition matrix, and also the definition was given. So the state variable is a function of the solution of state variable is the collective effort of the homogeneous solution added with the forced solution. And here I am writing this in terms of phi t minus tau d u tau d tau. So this is the solution of one. Similarly, solution of all. And if there is unforced system, only we will consider this part as the solution. Now some of the, if this is okay, this already we have done in the last class. Now if this is okay, then we are going for some property of properties of matrix and these properties, I will put this as a homework. Okay. And you will be taking this as a homework. You'll be solving one, and in the examination you can expect one proof. There may be one proof out of the properties, whatever we are writing. So first initially note the state condition matrix is something like this. This is our A, and this is nothing but I plus A T plus like factorial S squared T squared and so on. So this is the actual formula of your phi t. So what are the properties of phi t? Phi 0 is equal to identity matrix. This is the first property. All the properties we have to prove. The second property is phi t is equal to, or you can write down phi inverse t, not phi t, phi inverse t equal to phi of minus. This we have to prove phi of t1 plus t2, that is equal to phi of t1 into phi of t2, that is equal to phi of t2 into phi of t1. That we have to prove. This is the first property. The fourth one, phi t to the power n, that is equal to phi of n t. The fifth one is phi of t2 minus t1 into phi of t1 minus t0, that is equal to phi of t2 minus t0. Or this is equal to phi of t1 minus t0 into phi of t2 minus. So these 5 properties you have to prove. Is it okay? I request you to respond that whether you have noted all these 5 properties of STM or not, because you can expect this is as a homework. Please submit it as an assignment. This as an assignment. Now one proof we will do, but the rest of the proof you have to do. Is it okay? If you don't respond, it will be difficult for me to talk or continue. Hello? হ্যালো,
ইয়েস ম্যাম।
একটু রেসপন্ড করতে হবে, নাহলে কিন্তু আমাকে ধরে নিতে হবে আজকে যা পড়ানো শিডিউল ছিল সেটা পড়ানো হয়ে গেল। তোমরা যদি কথা না বলে একটু রেসপন্ড না করো, আমি তো বুঝতে পারছি না, আমি তো তোমাদের দেখতে পাচ্ছি না না। এইটা কি নোট করে নিয়েছো? Okay. So the first proof we will only do like there is the proof phi t equal to e to the power 18. You have to prove phi 0 equal to identity factor. So this will be proof. Now this is equal to I plus 8 plus 1 by factorial 2 square c square plus 1 by factorial I to the power I to the power I, and will go on. Now if T, when T equals to 0, phi of 0 is equal to pi. This one, and 62. That is equal to e to the power a into 0 x 2. So in this way, to prove all the, to make, you just need to consider this problem. And you need to make all other proofs. These are very simple proofs, so I will not do those proofs here, but you will be submitting this proof as an assignment. Now we will be doing one problem that is related to state variable analysis. Please write down the problem. Question number 2. Question number 1 is the properties of, you have to prove the properties of state transition matrix. Question number 2 is you have to obtain this, all you will submit. Obtain the time response of the following system obtain the time response of the following system. So what is that? X1, we have two state variables, X2 dot. It is equal to 1011 X1t X2t plus 11 ut, where ut is the unit step input, unit step input at t equal to 0, and the initial condition x transpose 0 is equal to 1 0. So the system has some initial condition, and ut is the step input. These are all given. And another thing is that, so given, so you have to, what is the objective? You have to obtain the time response of the system. Time response means you have to identify what is xt. This thing you have to identify. The solution of the state equation. Okay. So what is given here? We have two matrices here, A equal to 1 0 1 1. This is the system matrix. B equal to 1 1. X underscore transpose 0. Sorry, here it should be underscore. That is equal to 1 0. So these are all given. Now we have to identify, we have to find out the time response. So what is the time response? That is equal to the solution, that is equal to e to the power a 0 plus 0 to the power a minus tau d u tau. Here ut is equal to your unit step input d tau. This to find. So if I take e to the power at as bracket, if I take it common, so this will be, this is the something we have to find out. So first let us find out e to the power 80. E to the power 80, A is given here, 1011. So e to the power 80 is something like I plus 80 I request you to do this problem. So this is equal to something like 1001 plus what is A? 1011. 1011. C. What is A square? Can anyone please tell me what is A square? One by factorial 2. Can anyone please tell me what is A square? No one. None of you can tell what is A square. কেউ বলতে পারবে না? কেউ কি বলতে পারবে? What is A square? Multiply A with A.
1021.
Okay. Then you add all the matrix elements. So it will be something like 1. For the first element, it will be something like 1 plus C plus square by factorial 2 and so on. What is the second element? This 0, all the zeros added, so it is 0. The third one is 0 plus 1 plus C square, like that. 0 plus C plus square and so on. And the fourth one is 1 plus C plus C square by factorial 2, like this. So if it is like this, then the ultimate solution will be something like, what is this first one? It is a series, that is e to the power t. The second element is 0. The third element is, if you take t as common, then what you will get? It is t to the power t. And the fourth one is also e to the power t. So this is actually your result on 5. এইখান থেকে টিটাকে কমিয়ে নাও, তাহলে you will get t into, এটাকে যদি কোণ নাও, 1 plus t plus 1 by factorial 2 t square will be 1. So you take t as common and then you will get t to the power. এটা ঠিক আছে তো? This is the state transition matrix. So you may be asked as your question, number 1, obtain the state transition matrix. That is the first question. This may be the second question, the time is. Another thing you may be asked, that find the transfer function. And the fourth one is find the resolvent. So all you have to learn. But how to find out? Because already we have discussed everything. So phi t we have obtained. Phi t we got. We got t, that is we got t 0 t to the power t and it got 605. Now come to the solution. The solution is something like this. You need to calculate the homogeneous solution. You need to calculate the force solution. So for homogeneous solution, let us rewrite solution e to the power at x underscore 0 plus e to the power a t 0 to the power minus eta d u not u underscore u tau d tau. So first let us consider this one. So what is e to the power at x underscore 0? That is equal to the power t0. সবাইকে করতে হবে কিন্তু এই অঙ্ক করিয়ে দিচ্ছি পরে কিন্তু পরীক্ষার সময় ভুলভাল করবে না। Now what is this initial condition? Already given as a part of the problem. This is the initial condition. So given is x transpose underscore 0, that is equal to 1 cube. So we'll be writing this one the initial condition here. So what is the output? So বলতে পারবে হোমোজেনিয়াস সলিউশনটা কি হবে বলতে পারবে এই ম্যাট্রিক্সটা?
e to the power t plus t e to the power u.
e to the power t. তো এই পার্টটা হয়ে গেল। এবার এই পার্টটাকে দেখতে হবে। এই পার্টটা তাহলে we have to find out what is present within the integration. তাহলে ইন্টিগ্রেশনটা করো। 0 to t e to the power minus a tau e to the power at তোমার দেওয়া আছে তাহলে e to the power minus a tau হচ্ছে minus e to the power minus tau 0 minus tau e to the power minus tau আর e to the power minus tau। ঠিক আছে? d what is matrix? d matrix initially দেওয়া আছে দেখো d matrix 1 1। আচ্ছা u tau is unit step input মানে 1 d tau তার মানে what we are getting 0 to t e to the power minus tau 0 minus tau e to the power minus tau or e to the power minus tau multiplied to a matrix of 1 1. So what will be the outcome? 0 to t e to the power minus tau আর সেকেন্ড রোটা হচ্ছে minus tau e to the power minus tau plus e to the power minus tau যেখানে একটা ডিটাও লিখতে হয় তার মানে 0 to t e to the power minus tau d tau আর 1 minus tau e to the power minus tau d tau তার মানে ইন্টিগ্রেশন করতে হবে তাহলে ফাইনালি কি আসছে ইন্টিগ্রেশন 0 to t e to the power minus tau d tau আর সেকেন্ড ইন্টিগ্রেশনটা হচ্ছে 0 to t 1 minus tau e to the power minus tau d tau। এটা বলে দাও এই বারটা ওর ইন্টিগ্রেশনটা করতে হবে তার মানে একবার একটু লিখে নিই 0 to t e to the power minus tau d u d tau that is equal to first integration is 0 to t e to the power minus tau d tau and the second integration is 0 to t 1 minus tau e to the power minus tau d tau. So element wise you have to find out the integration. Element wise you have to find the integration. That I keep as a small. So once you do this, I'm writing out. But this solution you will when you need as an assignment. এটা তো দেখলেই বোঝা যাচ্ছে e টু দি পাওয়ার মাইনাস টাও কি হবে 1 minus e to the power minus t এই ফার্স্টটা e টু দি পাওয়ার m টাও এটা খুবই সোজা এই ইন্টিগ্রেশনটা করতে হবে দিস ইন্টিগ্রেশন ইউ হ্যাভ টু ডু তো এটার সলিউশন হচ্ছে t e to the power minus t এই ইন্টিগ্রেশনটার সলিউশন কিন্তু এটা করে দেখাতে হবে এটা লিখে দিলে চলবে না। আমি তোমাকে আনসারটা বলে দিলাম কিন্তু তোমাদের এটা করতে হবে ঠিক আছে তো ইউ আর গেটিং দিস এবার এখানে সলিউশন মানে কি অলরেডি ই টু দি পাওয়ার এই হোমোজিনিয়াস সেকশনটা পাওয়া গেছে এই পার্টটা আমার আছে অলরেডি কি এই সেকশনটা আর এই পার্টটা আমরা বার করে ফেলেছি তাহলে সবগুলো একসাথে যদি বসিয়ে দিই আমরা এক্সটি তে তাহলে সলিউশন উইল বি এক্সটি পার্ট কি ছিল ই টু দি পাওয়ার এটি এক্স জিরো তার মানে এই পার্টটা দিস পার্ট what is that e to the power t t to the power t plus e to the power at means এইটা e to the power t 0 t to the power t to the power t multiplied with this integration 1 minus e to the power minus t t to the power minus t. So if you make the solution, if you multiply and then add, the final result will be something like minus 1 and 2t to the power. So this is the solution of x. That means this is the solution of x1t and this is x underscore t, this one is correct. So what we are getting, first we are finding out, we need to obtain the solution time response of this system. So first we are obtaining e to the power at. We have the initial condition, we are calculating this integration, adding with the initial condition and multiplying with e to the power at. Or you can do e to the power at x0, you can multiply, you can get the solution as we did. And you can multiply this integration with e to the power at and then add them and get the solution. So this is the final response. Okay. Another thing is that you have to find out the characteristic equation. So what is the characteristic equation? Plus transfer function. So transfer function, what was the definition? Okay, first go with the characteristic equation. Si minus a equal to 0. This is the characteristic equation. So a already given 1 0 1 1. So what is Si minus a? A0 0 S minus a 1 0 1 1. This is the pure matrix algebra. I am not doing any pressure. S minus 1 element wise subtraction 0 0 minus 1 that is minus 1 S minus 1. So this is Si minus a. So if you find the determinant of Si minus a, that is the characteristic equation. So how you will find out the determinant? Multiply, make the cross multiplication. So S minus 1 whole square. That is square as plus 1 is equal to 0. This is your characteristic equation. Is it okay? And transfer function, we will be finding out. We all know the formula of transfer function. So please find out the transfer function of the system. 1 second. So transfer function is something like Psi minus A inverse you have to find out. B plus. So you need a C matrix. Then you need to calculate adjoint of Psi divided by determining that is the characteristics polynomial plus B. So you need everything A, B, C, D, then you can find out the transfer function. And another thing we are left with, I will be giving one problem finding out the transfer function. This is very easy to do. And we are left with one thing that is the fourth one, find out the resolvent matrix. That is equal to Laplace difference of phi. That is your resolvent matrix. Okay. If you can remember the formula, that is concept. So the fourth one is we have to find out the resolvent matrix, that is phi S, and that is equal to Si minus A inverse. This part you have to find out. Fine. And this is equal to, so phi t we can write down equal to e to the power A t, that is equal to Laplace inverse of phi S, that is equal to Laplace inverse of psi minus A inverse. So this is what we have as a part of your resolvent matrix. So how we are calculating the resolvent matrix? We may need to calculate. So phi, already the A matrix is given 1 0 1 1. So what is that minus A? That we did already. What is Si minus? This matrix. This one. So please rewrite this one. S minus 1 0 minus 1 S minus 1. So this is your resolvent matrix. This is your Si minus A. So you have to find out the inverse of this matrix. So inverse of this matrix means phi S equal to Si minus A inverse. That means inverse of S minus 1 0 minus 1 S minus 1 inverse. So for that one we need Si minus the determinant. Already we have calculated the determinant. Now adjoint of Si minus A, I know, hopefully you know how to calculate the adjoint. That means we have to keep, if we are finding out this element, then we'll be taking this element as a, we'll take this element here, Si minus A, minus 1, 0, then S minus 1. Then we have to change the sign. I think you know this thing. Plus, minus, followed by transpose. Si minus 1. You please find out the adjoint. S minus 1. S minus 1. 1, 0, S minus 1. This is the adjoint. Then we have to find out phi s. That means 1 by s minus 1 whole square. Adjoint means phi s means what? Si minus A inverse, that is equal to adjoint of Si minus A divided by determinant of Si minus A. So that is something like this matrix divided by S minus 1 whole square. So S minus 1, 0, 1, S minus 1. That means phi S is nothing but 1 by S minus 1, 0, then 1 by S minus 1 whole square and 1 by S minus 1. So this is your answer. This is the result of this. Phi S equal to 1 by S minus 1, 0, 1 by S minus 1 whole square, 1 by S minus 1. Now if you take the Laplace inverse, you will get phi t. Take the Laplace inverse. So you take what is phi t from here? 1 by S minus 1. That means it is power t. Then 0. This one is t to the power t, you all know. And this one is e to the power t. This is nothing but your phi t, where we have written phi t. This one is phi t, e to the power t 0, t to the power t, e to the power t. So the same thing is coming here. So from resolvent matrix also you can calculate phi t, or using the formula also you can calculate the phi t. That means if you have A matrix, what the first step is that to calculate phi t using this formula. I plus AT using this series number. Or from A matrix, you can calculate IX, the resolvent matrix. Then you can take the Laplace inverse and you can get phi t is equal to it. So there are two ways you can follow. Either of the way you can follow and you can find out the state transition matrix. So we have learned how to calculate the state transition matrix, the resolvent matrix, time response of the system from the state model, and the characteristic equation. All we have learned. So if you have any doubt, please let me know. Otherwise, we will move to another problem. বলো এগুলো জমা করবে কিন্তু all these you have to submit as an assignment. Question number 2. And this will be like I will tell you in the class also. You need to submit one assignment. So this week you need to submit as an assignment. I will give you a formal question also. But you consider all these questions very seriously. Keep a note of this. If you have any doubt, please let me know. Another question I'm giving, but as a homework, will not solve that. Same kind of question. Consider a control system. Consider a control system. Consider a control system with state model. A second order system is derivative of the state vector 0 to minus 2 plus 0 to 8. The initial condition is something like 0 1. You have to compute number 1, state transition matrix, number 2, resolvent matrix, number 3, find the state response, find the state response or the state response of the system, that is HP and T is greater than 0. The fourth one is obtain the characteristics equation. Also get the transfer function. Just make a small bit here. The state equation is given. Along with that, I am giving you the output equation. So with this output equation, you obtain the transfer function. That means y is s by. So please take a note of this question. With this, we are concluding the state equation related problem. Then we will do two problems related to controllability and observability. And with that, we will conclude this one. Okay. Please write down this problem and try to solve this one. Hello? Is it okay?
Yes, that is.
Okay. Now let us go for another problem. Just we will do two problem and we will conclude. Control observability. So please take the problem and find the controllability of the system. So you will be given with the state equation and you have to find the controllability of the system. So already we considered what is the meaning of controllability. Like your control input vector will control vector or input vector will control the states. So we have to consider a system equation like this. Consider system equation. Why devoting so much of time? Because you can expect some problem from, we will definitely get some problem from this chapter. And these are the type of problem we will get. So if you just follow these problems, then it will be easier for you in the exam. At least you will understand that what are the type of question you can get in your examination. So we are considering a system state equation, considering a system with state equation, with state equation as given below. 0, 1, 0, 0, 0, 1, minus 6, minus 11. At second, 1 second, please. Okay, sorry. So let us again start. Is my screen visible? Is the screen visible? Okay. So write down the problem. Zero, zero, 1, UT. So this is the problem. You have to find the controllability of the system. So you have to consider, first one thing is that you need to see step 1, whether the system is represented in canonical variable form or not. Whether the representation is in canonical variable form or not. It is not in canonical variable form. Presently we can see. Is in canonical variable form or not. If it is not, then if you are applying Gilbert's test, please consider properly. If you are considering Gilbert test method of identifying or testing controllability of the system, then you have to translate the state variable into canonical variable. Any form of state variable into canonical variable. And then you check this B matrix. B matrix, this matrix, B matrix. Bi should be not equal to 0. If any of the Bi is equal to 0, then the system is not controllable. But since this particular representation is not in canonical variable form. So by observing the B matrix, we can't comment anything. So you have to translate this representation into canonical variable form, and then you will apply the Gilbert test method. So this is your first assignment. You are given with this system. Obtain the representation number, obtain the above state variable representation in canonical variable. Canonical variable. So this is the first task. If you do so, you will see the answer I am giving you. Just you need to compare the answer. The canonical variable representation of the above system is this: -1 0 0 0 -2 0 0 0 -3 plus V1 V2 V3 plus half -1 half. Now you can see all the elements of the matrix are non-zero. That is not equal to 0. So the system is controllable. We can say by observing this B matrix in canonical variable form, the system is canonical variable form. But you have to specify this one, state variable to canonical variable representation, that you will do in terms of matrix diagonalization. I told you earlier that matrix diagonalization we have to find out. These are all the eigenvalues of system, -1, -2, -3. They are the poles of the system also. Eigenvalues are actually the কেউ একজন বলো কতটা অবধি দেখেছো? স্ক্রিন শেয়ার করছি। কন্ট্রোলেবিলিটি, অবজারভেবিলিটি কতটা অবধি দেখেছো? এই অবধি দেখেছো তো? হ্যালো,
I'm just a canonical variable from the legal.
আচ্ছা আচ্ছা, ঠিক আছে, ওকে, আমি এখানে মিস করলাম। ওকে, ওই অবধি লেখা হয়ে গেছে, আমরা বেশি দূর আর করিনি। লাইক one is the Gilbert method. So what you do, you test variable, from that you get the canonical variable, and you test the B matrix. Bi not equal to 0, so your system is controllable. And another method is the Kalman test method. There already we discussed in the last class. We have to create a controllable matrix for any other system. The matrix will be something like this. It will be something like B, AB, A square B, and so on up to the power n minus 1B. If you get the matrix, you find out rank of QC. If rank of Q is equal to n, then the system is controllable. Otherwise not. So for this problem, -6, -11, and what is there? Again, let me get the matrix. -6, -11, -6. Plus, what is B matrix? 0, 0, 1, U. So this is the state equation. So here, n is equal to 3. So your controllable matrix will be something like B, AB, and A square B. So this is your controllable matrix. Now B already we know what is B. B is 0, 0, 1. So you place 0, 0, 1 here. What is AB and A square B? That you will calculate and you will give me the answer. এটা কি হবে? AB আর A square B টা কত হবে আমাকে বলো। বেশি দূর আমি এগোইনি। What is AB? একটু বলো প্রত্যেকে। হ্যালো, হ্যালো, বলো। হ্যাঁ, করো। AB and A square B. যারা আছো কলে, আমি সবাইকেই রিকোয়েস্ট করছি একটু করো, because this kind of problem you will get in your exam. কারো হয়েছে এটা এবি?
এবি হচ্ছে 0 1 -6
-6 আর a স্কয়ার করে ফেলো। আই এম ওয়েটিং, করো, করে আমাকে বলো answer।
-1 -6 20
ঠিক আছে। আরেকবার বলো। 1 -6
25
right. Now you have to calculate the rank of this matrix. If rank is n, rank is 3, rank কি করে বার করবে? You have to calculate the determinant of QC. Determinant of QC যদি exist করে, যদি নন জিরো হয়, এবার determinant of QC কি আমরা দেখতে পাচ্ছি? exist করছে, দেখো, that is 0 into this part, that doesn't exist. 0 multiplied by this one, for this one it is -1. So determinant of matrix is not equal to 0. That means rank of this matrix is equal to 3. That means the system is controllable. Both from Gilbert test and the Kalman test, we find that the system is controllable. Similarly, another problem I am giving to you for identifying the observability. So please take that problem. Observability, already we have identified that we need to observe the state from the output variable. So if the C matrix, in that case, the C matrix, that means the output matrix, like y equal to cx plus du. So output matrix, if you want to observe the state from the output variable, then all the elements of C matrix should exist. So that is the requirement for Gilbert test based method. আচ্ছা, এক সেকেন্ড, একটুখানি আমাকে লিভ করতে হচ্ছে। I'm not leaving, but one second. Okay, sorry. Let us again start. अच्छा একটু প্রবলেমটা লেখো the state equation. Let us examine the observability of the system given below. Examine. Is it visible, the screen? Is the screen visible? Okay. Observability of system given below. So what is the system? System is something like so this is your system equation, out equation. We have to find out the observability of the system. So one thing is that you can see that this is not the representation in canonical variable form. So if you are going with observable with Gilbert testing method, again you have to translate this system from state variable form to canonical variable form, and from there you have to test that whether this C matrix is non-zero or not, whether Ci should be not equal to 0 for observability, because you can observe all the output variables from this state only the connections are on. Otherwise, if any of the element is 0, that means x1 is not directly connected with y. So for that one, all the elements of the C matrix in Ci is not equal to 0. That is the first constraint. The second thing is that if you are not going with, that is the first step of Gilbert testing method. But it's not state, don't go with Gilbert testing method, because Gilbert testing method is easy to observe, but you have to translate the system in canonical variable file. Next test will be Kalman testing. Kalman testing. So how we will do that? We define an observability matrix for nth order system. Observability matrix for nth order system. So what is that observability matrix? That is something like C transpose, A transpose, C transpose, A transpose whole square. You have to construct the observability matrix like this. For nth order system, it will be something like this. A transpose n minus 1, C transpose. If the rank of QC is equal to n, then your system is observable. Otherwise not. Now, for this problem, n is equal to 3. The problem whichever we are discussing, n equal to 3. So you have to construct a matrix like this. Q observable is something like C transpose, A transpose, and A transpose whole square, C transpose. So what is your C transpose? C transpose is 3, 4, 1. Now I request you to calculate A transpose, C transpose, and A transpose whole C transpose. Give me the values and check whether the determinant of the matrix exists or not. If it exists, then the rank is 3. System is observable, otherwise not. একটু পরপর আমাকে করে বলো, what is A transpose C transpose? Already we get A C transpose, A transpose আর A transpose whole square C transpose. এই দুটো আমাকে একটু করে বলো। এদিকে একটু এটা আম রাখা আছে একটা বাইরে, ধরো কাঁচা, ওটা একটু ছাড়িয়ে কেটে একটু নুন হলুদ মাখিয়ে রেখে দেবো, একটু পরে যাচ্ছে। নুন না হলুদ, হ্যাঁ ঠিক আছে। এক মিনিট শোনো, আমাকে A ট্রান্সপোজ আর C ট্রান্সপোজটা বলো।
uh, 0 1 1
0 1 1 and ব্যাপারটা বলো। এক মিনিট শোনো, এক মিনিট শোনো। দীপিকা শোনো, বলো A ট্রান্সপোজ হোল স্কয়ার C ট্রান্সপোজ কথা বলো।
-2 -2
ওকে, তো এই 0 -2 -2 if it is like that, এই তিনটে এবার দেখো র্যাঙ্ক কত বলো। কিউ কিউ ডিটারমিনেন্ট কি এক্সিস্ট করছে না করছে না? মানে ডিটারমিনেন্টের ভ্যালু কি নন জিরো না জিরো, সেইটা আমি জানতে চাইছি। তোমরা ডিটারমিনেন্ট বার করতে জানো নিশ্চয়ই। কি বলো, ডিটারমিনেন্টটা কত?
0 আসছে।
জিরো আসছে, তাহলে যদি সে তাহলে ডিটারমিনেন্ট যদি নন জিরো হতে হবে, তাহলে র্যাঙ্ক ইজ নট 3, র্যাঙ্ক নট ইকুয়াল টু 3, সো দিস সিস্টেম ইজ নট পসিবল। এবার র্যাঙ্ক কত আমার ইনপুট, কিন্তু আমি নট অবজারভেবল বুঝতে পারবো যদি ডিটারমিনেন্ট জিরো হয়, তাহলে র্যাঙ্ক ইজ ইকুয়াল টু 3. So this is what we have under state variable analysis. আমরা মোটামুটি এটা কমপ্লিট করলাম। আমি কতগুলো প্রবলেম তোমাদের দেব, দ্যাট ইজ আন্ডার দ্য নেক্সট চ্যাপ্টার, ইজ দ্য লাস্ট চ্যাপ্টার, ইজ ইন্ট্রোডাকশন টু ডিজাইন। এই প্রবলেম গুলো করতে হবে, ইন্ট্রোডাকশন টু ডিজাইন। পরের উইকে মানডে ফ্রাইডে ক্লাস হবে না, তারপরে নেক্সট ফ্রাইডে কি মিড সেম না মানডে টিউসডে মিড সেম? মিড সেমের ডেট কবে তোমাদের?
ম্যাম নেক্সট ফ্রাইডে ছুটি আছে 1 মে।
না আমি জানি নেক্সট ফ্রাইডে ছুটি, আমি বলছি তার পরের সপ্তাহে।
না ম্যাম তারপরে সপ্তাহে নেই, 11-12 হচ্ছে আমাদের
না
মিড সেম।
4 তারিখ বাদ দাও, 4 তারিখ তো বাদ দাও, 5 তারিখ অনওয়ার্ডস তোমাদের বোধহয়, মানে নেক্সট উইক, নেক্সট মানডে এখনো কিছু ডিক্লেয়ার হয়নি, তো নেক্সট মানডে আপাতত অনই আছে যদি কিছু নোটিশ না আসে। তো পরের সপ্তাহে ফ্রাইডে অফ আছে, এবার তারপরের সপ্তাহে তোমাদের ক্লাস হবে, তাই তো? মানে আমার আর হয়তো 2টো ক্লাস লাগবে। এবার আমি দেখছি এর মধ্যে কিভাবে ম্যানেজ করা যায়। আমি কয়েকটা প্রবলেম আজকে দিয়ে যাচ্ছি, এর মধ্যে যদি কোনো ক্লাস তোমাদের অফ থাকে আমাকে একটুখানি ইনফর্ম করো। মানে আমি ফ্রাইডে ক্লাসটা তো নেব, আর যদি ইন কেস আগে কোনো ক্লাস অফ তোমরা পাও তাহলে আমাকে একটু জানিও, আমি তাহলে চ্যাপ্টারটা কমপ্লিট করে দেবো। ঠিক আছে, আমি কতগুলো তোমাদের রুট লোকাল স্লট করতে দিয়ে যাচ্ছি, বিকজ দিস আর ভেরি ইম্পর্টেন্ট ফর দিস ডিজাইন। This is the last chapter we will be studying. Under this chapter we will be studying whatever in the syllabus, PID controller, proportional integral, derivative controller. আমি অ্যাকচুয়ালি এটা একটু ক্লাসে পড়াতে, আমি অনলাইনে পড়াতে চাইছি না, সেই জন্যই আজকে আমি কিছুটা দিতে পারতাম, বিকজ দিস পার্ট ইজ পিওরলি কনসেপ্ট। তুমি এতদিন কি বুঝেছো তার উপরে এই রিজাল্টটা ডিপেন্ডেন্ট, যেটুকু আমরা পড়বো। তো আমি সেটা বেসিকটা এবং এইটা আমি যদি একটু রিভিউ করি এই চ্যাপ্টারটা পড়াই, অ্যাটলিস্ট ইট উইল রিভিউ দ্য এন্টায়ার কন্ট্রোল সিলেবাস ইনক্লুডিং ইউর টাইম রেসপন্স অ্যানালিসিস, ফ্রিকোয়েন্সি রেসপন্স অ্যানালিসিস। তো তাই জন্যই আমি এই চ্যাপ্টারটা ক্লাসে পড়াতে চাইছি। মানে লাইক এখানে কোনো রকম ওরকম বিশাল বড় বড় থিওরি এটসেট্রা সেরকম কিছু নেই, পিওরলি প্রবলেম বেসড। এবং এই চ্যাপ্টারটা না পড়ালেও এই চ্যাপ্টারের মধ্যে যে প্রবলেম গুলো আছে আমি যদি দিই তোমাদেরকে করতে, ইউ উইল বি এবল টু সলভ। বাট সাম কনসেপচুয়াল অ্যাসপেক্টস আর দেয়ার হুইচ উইল ফাইন্ড ইন গেট কোয়েশ্চেন অর আইএস এর যদি তোমরা কোনো পরীক্ষা দাও, ইন্ডিয়ান ইঞ্জিনিয়ারিং সার্ভিস, সেখানে যেরকম টাইপের কোয়েশ্চেন আছে, মানে কনসেপচুয়াল যে কোয়েশ্চেন্স গুলো, সেই কনসেপ্টটা এখানে মানে what is your observation like till now whatever you have studied, like starting from your very beginning of the course, তুমি এতদিন অবধি কি বুঝলে? কিছুই বুঝলে না তো আনন্দের ব্যাপার, কিন্তু যদি কিছু বুঝে থাকো সেই বোঝাটাকে ব্রাশ আপ করা, এবং যারা বোঝোনি তাদেরকে বোঝানোর দায়িত্ব আমার। তো সেই জিনিসটা আমি একটুখানি আই ওয়ান্ট আ ডিসকাশন কাইন্ড অফ থিং, and we will be completing this thing, PID controller, like proportional controller. যারা বোঝনি সেটা ভালো নয়, সেটাই আবার আমাদেরকে ঠিক করতে হবে, আর বুঝে থাকলে তো খুবই আনন্দ কথা। PI PD controller আর PID controller অ্যাকচুয়ালি এইটুকুই পড়বো, কিন্তু এইটা তোমরা পড়লে চ্যাপ্টারে যা কোয়েশ্চেন আনসার আছে কয়েকটা টিটবিট আছে, দ্যাট ইজ ভেরি ট্রিভিয়াল, কিন্তু this chapter gives you a pure conceptual understanding about control system, like some kind of feeling, like how you can utilize all the tools till now whatever you have studied. So I will request, I will prefer rather, not request, I will prefer rather to take the class in offline mode. But if we see that if nothing, no option is left, like আমাদের যদি কিছু অপশন না থাকে তাহলে আমাদের অনলাইন ক্লাস মোডেই যেতে হবে, কিন্তু একবার আমি ট্রাই করতে চাইছি। তো দেখা যাক নেক্সট উইক যদি ক্লাস থাকে। আমি কতগুলো প্রবলেম তোমাদের দিয়ে যাচ্ছি, এগুলো পারলে একটু করে রাখবে। ড্র দ্য রুট লোকাস প্লট। নেক্সট দিন এই চ্যাপ্টারটা পড়ার জন্য ক্লাসে আসবে, করে রাখা সুবিধা লোকাস প্লট। ওকে, সো 2 categories of root locus plot we will do. G1 is equal to A divided by S plus 2. G to S. We are adding poles actually. A divided by S plus 2 into S plus 4. G is A divided by S plus 2 into S plus 4 into S plus 8. This is one set of problems. You will be doing it together, one after another. Random করে করবে না, like 1 2 3 পরপর সিকুয়েন্সিয়ালি করবে এবং প্লট গুলো পরপর রাখবে। লাইক ইভেন্চুয়াল যে লাস্টের যে এন্ড প্লটটা পারলে একটা পেজে পরপর 3টে প্লট উপরে ট্রান্সফার ফাংশনটা লিখে পেস্ট করে রাখবে। আচ্ছা, নেক্সট হচ্ছে effect. These are adding poles. What is the effect of adding poles in system performance that we are studying? Now some transfer function will give you the understanding of effect of adding zeros. So this is a transfer function, S into S plus 2 S plus 5, no zero. S plus 7 S into S plus 2 plus 5. GCS K divided by K into S plus C, S into S plus 2, S plus 5. And D4 is K divided K into S plus 1, S into S plus 2, S plus 5. These are the 4 root locus plot again. 1, 2, 3, 4. So here poles are constant, but we are adding zeros in different locations. So এই 7টা root locus plot আমাদের করতে হবে, আর এছাড়া এটা করতে হবে, কিন্তু না করলে কিন্তু পরের দিনের অঙ্কগুলো বোঝা যাবে না। We need this root locus plot. আর এছাড়া আমি একটা ইন্ডিপেন্ডেন্ট root locus plot দিয়ে যাচ্ছি, এটা আলাদা। A divided by S into S square plus 4. What is the root locus plot of this? এবার এই সবকটা root locus plot যদি আমাদের কাছে থাকে, আমরা খুব সহজেই will be able to, আচ্ছা আর একটা দিয়ে যাই, এটা ঠিক আছে, এটা করতে পারলে ভালো, পরীক্ষার সময় help হবে। S plus 2, S plus 3, S plus 4, that is equal to GS. So for all these transfer function, actually these 3 will go together, these 4 will go together, this transfer function has some implication, and this also has some implication. So I will request, so 4, 7, 7, 8, 9, 9 root locus plot. So once you are coming in the next class, it is better you come prepared with this 9 root locus plot, and I give you as an assignment to submit all these 9 root locus plots. And also the assignment, state variable analysis we have done. Root locus plot assignment, all these assignment you submit. Stability analysis, earlier assignments, most of you have submitted. So if possible, you submit all the others. Not if possible, these are the problems given, so you submit the assignment. All these 9, 3 plus 4 plus 8 and 9. The root locus plot of all these 9 transfer function. And don't do it randomly. Do these 3 together, these 4 together, one after another in one place, 3 together, one after another in another place. This will tell you about the effect of adding poles in system performance, effect of adding zeros in system performance. This is about one transfer function, how it is independent transfer function. This is also another independent transfer. So with that, today I conclude the class. So if you have anything to tell, you may let me know. And regarding the attendance, I will request that, okay, 1 second. Okay. Consider it now, I can write it now. আচ্ছা আমাকে একটুখানি পরপর আমি পরপর নাম বলে যাচ্ছি, আমাকে এগুলো একটু বলে দাও। আচ্ছা, Adrija, are you present, Adrija?
Yes, ma'am.
What is your roll number?
458.